Hi boys and girls, welcome to lesson 1-3 for course 2, 4th period in Mrs. Bandu's class. Today we're going to look at multiplying decimals. The identity property of multiplication, we'll look at our key concepts first, tells us that the product of 1 and A is A. So basically 1 times anything is that other number. So if I look at it with numbers, 5 times 1 is 5 and 1 times 5 is 5. If I look at it with variables or letters, A times 1 is A, or any number times 1 is that number. Also 1 times A is A. So the product of 1 and any number is that number. Let me see if I can focus that just a little better. There we go. All right, the 0 property tells us that the product of 0 excuse me, I started writing in the wrong place. The product of 0 and any number is 0. Okay, so that tells us 5 times 0 is 0, or 0 times 5 is also 0. If we look at it with variables, A times 0 is 0, and 0 times A is 0. So anything we multiply by 0, we get 0. That's what it tells us. Okay, the commutative property of multiplication is very similar to that commutative property of addition. Changing the order of the factors does not change the product. Okay, just a quick review here. Factors are the numbers in the multiplication problem, right? And the product is actually the answer to a multiplication problem. So the factors 5 times 2 give you the same result as doing 2 times 5. Just like when you learned your multiplication tables, once you learned a set, you actually learned 5 times 2 and 2 times 5. If I have any number times 2, it's the same as 2 times any number. Okay, so I can change the order without changing the value. Here we can see that on both sides, 5 times 2 is 10 and 2 times 5 is 10. Here, since we don't know the value for A, we can't prove it as easily, but okay. And lastly, we have the associative property of multiplication, and again, very similar to that of addition, changing the grouping of the factors, or of factors, does not change the product. Okay, so this has nothing to do with mixing up the numbers. It just talks about putting them in different groups. So if we look at the arithmetic one, we have first 3 times 2 grouped together times 5. That tells us that's the same as if we took 3 times 2 times 5 grouped together. So if you want to do a quick check mathematically, 3 times 2 is 6, times 5 is 30. Here, following order of operations, 2 times 5 is 10, times 3 is 30. So the result here is the same, even though the grouping is different and order of operations would have us do it a little bit differently. In the algebra one, we see that A times B, the quantity A times B times C, is the same as A times the quantity B times C. Again, not as easy to prove when we don't have numbers in, so this one probably makes a little more sense at this stage of the game. Okay, so let's look at our first example that we have here. First of all, we can estimate so that we know if our answer is somewhere in the ballpark. So we're going to round 11.4 to 11 and 3.6 to 4, so that our estimate is 44. So that tells us our answer has to be somewhere around 44. The second step is to find the product. Remember, product is the answer to a multiplication problem. Okay, so we multiply as if the numbers are whole numbers. So you line them up. I actually usually keep my decimal points in here just so I don't forget about them, but you don't have to line up the decimal points. All right, so I'm going to multiply. 6 times 4 is 24, carry a 2. 6 times 1 is 6 plus 2 is 8, nothing to carry. 6 times 1 is 6. Obviously that was done for you, but I wanted to go over it. Here when I multiply by the 3, some of you learn to put in an X, some of you learn to put in a 0. The first product I get, 3 times 4 is 12. I want to line it up under the 3, which then lines it up under the 8. So write down the 2, carry the 1. 3 times 1 is 3, plus 1 is 4, and 3 times 1 is 3. At this point, I am now ready to add. 4 plus 0 is 4. 8 plus 2 is 10. Write down the 0, carry the 1. 6 plus 4 is 10, plus 1 makes it 11. So write down the 1, carry a 1. 3 and 1 is 4. So my answer here, the numbers in my answer are 4104. Okay. And I'm just going to copy this 4104 over here and just copy it over here. In real life, you wouldn't actually write it twice, okay? Now, after you do all of that, we want to locate the decimal point in the product by adding the decimal places of the factors. So here is one decimal place in that factor. Here's a second decimal place in that factor. So there are 2 decimal places behind the decimal point in the factors. So that means there needs to be a total of 2 decimal places, 1, 2, behind the decimal point in my answer. Okay, so the product of 11.4 and 3.6 is 41.04. The product, 41.04, is close to the estimate of 44, so it's reasonable. Remember, our estimates in multiplication and division are not going to be as close as those we might get in addition or subtraction very often. Okay, don't let that panic you, but just so you're aware of that. Okay, let's go to our next page for our next example. So you do need to turn your page for example number 2. And this one asks us to use mental math to find 2 times 4.097 times 0.5. Okay, now what this wants us to do is let's look for some things that might be easy to do together. Okay, I should look for compatible numbers. Remember, compatible numbers are those that work together very easily. The product of 2 and 0.5, remember 0.5 is the decimal name for 1/2, is 1. Then the product of 1 and 4.097 is 4.097. Okay, so I talked through that. Let's also look at why something like that would work. Okay, here we go. First of all, I can apply the commutative property of multiplication. Oftentimes we do this automatically without thinking I'm applying the commutative property, which doesn't make it wrong. It just means we actually have a name for that. So by and then, okay, so I move them together and then associating them, putting them together, so I'm going to do them first, all right? I can insert those parentheses and then times 4.097. So really what a lot of people do in their head is an application of the associative and then commutative properties of multiplication. 2 times 1/2 is 1 whole, because two halves make a whole, and 1 times any number is that number, which in fact is the identity property of multiplication. Okay. So that was a quick run through on what we need to remember about this. Remember, just to recap, you do not line up the decimal points in multiplication. You want to line up by digits. Once you've done the multiplication as if the problem were in whole numbers, go back, count the number of places, total places in the factors, and have that total number of places be to the right of the decimal point in your final answer as well. Okay, remember you can stop and rewind any of this that you might need to. What I'd like you to do is also be sure that you have completed the quick check questions, which are these 3 questions right, well actually 4 questions right here on the back, 1, A, B, and C, and number 2. Okay, please write down your work, follow the steps so that if you have questions you are able to ask them. Thank you.